To help reinforce our understanding of this distinction between deductive inferential claims and inductive inferential claims, as well as to better facilitate our quick identification of arguments as having deductive or inductive inferential claims, let's go ahead and review a number of typical deductive kinds of arguments and a number of typical inductive kinds of arguments. So arguments that have the form of mathematical relationships other than probabilistic and statistical relationships are likely exploiting the deductive character of mathematical inference in order to formulate a mathematical argument. So for instance, if someone presents you with an argument, I've got one toonie, which is a $2 Canadian coin, one loonie, a $1 Canadian coin, and 4 quarters, hence I've got $4. They're using the deductive structure of those mathematical relationships to formulate a deductive argument. When we define something, we will specify the conditions that are individually necessary and jointly sufficient for an instance of that kind of thing. That is, we'll specify how to classify something as an instance of that kind of thing or to rule it out as an instance. And that structure, again, facilitates its use in deductive arguments. And so arguments from definition will start off with a definition, and then they'll use a deductive inference to exploit that definition in order to draw a conclusion. So an example of that might be a syllogism is a 3-line argument. There's our definition. Hence, your argument is not a syllogism as it has 4 lines. Other examples of deductive arguments include categorical syllogisms, 3-line arguments, the underlying structure of which is relationships between classes of things. So an argument that is an instance of a categorical syllogism and hence a deductive argument might be something like all elephants are mammals, some elephants are quadrupeds, therefore some mammals are quadrupeds. Hypothetical syllogisms are also 3-line arguments, but hypothetical syllogisms have at least one premise that is a conditional statement. So if you want to vote, then you need to register by the deadline. You want to vote, so you need to register by the deadline. Again, a hypothetical syllogism leverages that conditional relationship between antecedent and consequent in order to draw out a deductive conclusion based upon that relationship. Disjunctive syllogisms do the same thing, except they leverage the relationship in a disjunctive statement, a statement that says either this or that. So the Ken Casey syllogism that defined the 60s, for example, was either you're on the bus or you're off the bus. You're not on the bus, so you're off the bus. Even this relatively abbreviated survey of typical kinds of deductive arguments is sufficient for a pattern to start to emerge. What we notice after a short while is that these deductive arguments all leverage underlying structural relationships between content elements, relationships that exist regardless of the specific content of those elements, and they utilize those relationships to establish the connection between the premises and the conclusion, such that if the premises are true, no matter what they are about, those underlying structural relationships will guarantee, they'll act to guarantee that the conclusion will also be true. When we turn our attention to inductive arguments, the nature of the inductive inferential claim changes, and hence a different mechanism needs to be employed to relate the truth of the premises to the likely truth of the conclusion in a strong inductive argument. And so we find with inductive arguments is that they will take advantage of any number of different regularities that exist in our experience, reliable ways in which the world unfolds, leveraging those, introducing a certain amount of risk in order to try and guarantee that when the premises are true, it is very likely that the conclusion will also be true. For instance, arguments from analogy leverage analogical relationships in our experiences. An analogical relationship in our experience comes when we observe that two things or classes of things share a number of important or significant properties. Once we observe that relationship, we can then make an inference based upon that observed relationship and go ahead and infer in our conclusion that these two things share another property that we haven't verified that they share. And thereby we incur a little bit of epistemic risk, but we do so in a way that makes our conclusion likely to be true given the observations and the information that we do have based on this analogical relationship, this regularity in our experiences. So for instance, if we observe Pintos are manufactured by the Ford Motor Company and Tauruses are manufactured by the Ford Motor Company, and we observe that Pintos suck, we may well use an analogical inference to infer that Tauruses suck. Now this inference, while it may make our conclusion more likely to be true than by chance or than it was prior to our making this inference, it's not guaranteed to be true. So Pintos are manufactured by the Ford Motor Company, and the 1967 Fastback Shelby Mustang was manufactured by the Ford Motor Company. And while Pintos definitely suck, the 1967 Fastback Shelby Mustang was in fact the production car of the year in the year that it was first manufactured, and hence it, by definition, was agreed didn't suck. And so it's possible for our premises to be true without guaranteeing that our conclusion is true, because we're leveraging regularities in our experiences that aren't necessarily universal in their existence. Inductive generalizations work in a similar fashion. Inductive generalizations look at a number of observations that we've made. They find an exceptionless pattern, and then they make an inference that that pattern will be propagated in future observations. Usually they infer that it will always be the case. And so if we observe that the sun has risen every morning since we were born, we may well infer that it will rise again tomorrow, or that it will always rise. Arguments from authority leverage the superior epistemic position of people who've devoted some degree of their life to studying some topic. They are more likely to know the truth about that topic than the average person. And so we'll leverage their authority in order to make an inference, which again isn't guaranteed, but is rendered much more likely on the basis of their authoritative pronouncements than it would be based on other people's pronouncements. So for instance, many NASA scientists believe that life might have existed on ancient Mars. Therefore, it's likely that life existed on Mars in the past. Other types of inductive arguments have different principles. Arguments that are based on signs or indicators, they seek to leverage a reliable correlation that exists in our experience between one feature of the world and another feature of the world. So again, the 1960s kind of inference based on signs or indicators might be something like this. Blue bruising indicates that a mushroom likely has hallucinogenic properties. This mushroom bruises blue, hence it likely has hallucinogenic properties. But again, truth of the antecedent premises doesn't guarantee the truth of the conclusion. And so we're always taking a certain amount of epistemic risk when we make that inductive inference based on signs or indicators. Causal relationships are also relatively stable, reliable relationships in our experience, and so they are often exploited for the purposes of making inductive inferences. So for instance, smoking causes increased risk for developing cancer. You smoke, hence you're at increased risk for developing cancer. We'll finish this second arguments lecture by turning our attention to the third step in that four-step process of identifying, extracting, and evaluating arguments. We'll turn our attention to evaluating arguments in terms of their logical form. And specifically, we're going to focus on deductive arguments, and we're going to learn how to use the counterexample method. Now, we normally already use the counterexample method in real life, as we'll see. However, we want to do it in a more systematic and thoughtful fashion so that we're more likely to get an effective result. We'll start by learning how to extract the underlying structural relationships that are so crucial for a good deductive argument so that we can portray those relationships and then substitute in new content to illustrate the weaknesses of bad deductive arguments, thereby differentiating them from good deductive arguments on the basis of their underlying logical structure.